we were talking about analyzing graphs of polynomial functions, and we want to identify even and odd functions algebraically. And so we're going to look at, here's the check over here. If it's an odd function, the function evaluated at negative x is equal to the entire function negated. And an even function, then we can check the function evaluated at negative x is equal to the original function f of x. Right off the bat, we see that the highest degree of the function is 6, which is even. So pretty sure it's not going to be an odd function, but we can just run through the test just as an example. And what we want to check for, the first thing is we want to negate the entire function. So negative the entire function, that is equal to negative times negative x to 6 plus 3x to the 4th minus 2x squared minus 7. So when we distribute the negative to all the terms, we get the function negative f of x is equal to a positive x to the 6th minus 3x to the 4th plus 2x squared plus 7. So that is the negated function. Now we want to check what we'll get if we have the function evaluated at negative x. So we take the function and we have it evaluated at negative x, and that is going to be equal to negative times negative x to the 6th plus 3 times negative x to the 4th minus 2 times negative x squared minus 7. So all we did was substitute a negative x for all the x values, and then let's see what happens. Because it's an even degree, we know that negative x to the 6th, that actually doesn't really affect it. And so the negative under the radical kind of disappears, and we're just left with the negative out front. So that becomes negative x to the 6th. Same thing here. We have negative x raised to an even power. So eventually that will be a positive value that we get there. So that's going to be plus 3x to the 4th. The negative 2 comes down, and then we have negative 6 or negative x raised to the 2nd power. So again, that value drops out, and we're just left with x squared and nothing with the negative 7. So then we can check the function evaluated at negative x. We see that our highest degree of coefficient is negative 1. And up here, the negative function, the lead coefficient is positive 1. So these two are not equal. So negative the function at x does not equal the function evaluated at negative x. And so this one is not odd. And then we can check for even. We can check the function evaluated at negative x is negative x to the 6th plus 3x to the 4th minus 2x squared minus 7. And that's it. So that's we have negative 6 or negative x to the 6th plus 3x to the 4th minus 2x squared minus 7x. And so we do know that the function evaluated at negative x is equal to the function evaluated at x. And so this one is even.